Hey everybody, good morning. Welcome to science class. So we talked about conduction on Tuesday, and today we're going to be talking about two other ways that heat transfers, convection and radiation. So we're going to be reading first and then going over some of the major concepts in our PPT. And then we will do our workbook page 69 to review everything from this week, all right? So let's go ahead and review what we talked about on Tuesday before we get started. So we talked about heat and what that means. So heat is the transfer of thermal energy from one substance to another substance. And heat always travels from a warmer place to a cooler place, right? And the three ways that heat transfers or moves are conduction, convection, and radiation. A couple key points about conduction. So conduction is a heat transfer that happens when particles inside the matter bump into each other, but they don't change the location. They stay where they are, but they vibrate when they are in contact with heat. And this usually happens in solids, like a pot. And if you think about putting a pot on top of the fire and you're trying to cook some sausages, and the heat will get in contact with the pan, causing the particles to move faster, and then the heat will transfer onto the sausage. So it needs direct contact, right? It needs to be touching the heat. Now, let's move on to convection and radiation. So let's go ahead and read first. So if you would prefer to read alone, you can pause now, read pages 98 and 99 on your own, and then skip ahead to the section where we review the concepts, all right? Otherwise, let's go ahead and get started. Convection. In conduction, the particles transfer energy, but they do not move from one place to another. But not all heat transfer works this way. Convection is heat transfer that occurs when particles carry thermal energy as they move from one place to another. Convection usually occurs in liquids and gases. For example, as you heat water, only some of the water particles touch the bottom of the pan, and these particles are heated by conduction. As they get hotter, they move faster and spread out. This spreading out makes the water at the bottom become less dense. The particles in the hotter water are pushed up as the particles in the cooler, denser water above sink. So it goes up and down and up and down. The new cool particles at the bottom are then heated, and then the entire process starts again, and this is continuously repeated. And this movement of the particles is called a convection current. The current moves particles that carry thermal energy from one place to another. You have probably seen the convection currents in a pan of boiling water. There are also other kinds of convection currents. Huge thunderstorm clouds are caused by convection currents in the air, and most geologists think that the hot rock under the Earth's crust flows in this type of current as well. So if you're boiling water for some ramen, you probably have seen the water particles moving around. That is a convection current. Cool. How about radiation? So just think about the sun, how we're getting heat even right now through my window, getting some heat, right? Let's read about that. Radiation is heat transfer that occurs when there are no particles to carry the energy. Both conduction and convection need matter for heating. So it needs a matter. However, radiation happens without particles directly touching or particles moving. So you don't have to touch. The transfer of thermal energy is indirect, and radiation can also occur through empty space. For example, solar radiation or energy from the sun is an important source of both heat and light for the Earth. The sun heats the Earth even though a great distance separates them. There is no matter that can be used to transfer the energy of the sun to the Earth. We don't have a ship or a plane carrying the heat from the sun to the Earth, right? It just radiates. Yet energy from the sun still reaches the earth by radiation. Much of this solar radiation is absorbed by the earth and converted to thermal energy. Not all substances absorb the same amount of radiation. The amount depends on the type of surface the substance has. Dark colors absorb radiation better than light colors do. This is why you feel warmer in the sunshine when you wear dark colors, dark clothing, than when you wear light clothing. So that's why in the summer it's recommended that you wear like white shirts. It'll keep you cooler. The sun is not the only source of radiation though. The glowing coils of a toaster use radiation to brown your bread. You can also feel the warmth of radiation from a glowing light bulb. All three forms of heat can be observed in a campfire. Conduction heats the air particles that directly touch the fire. As the thermal energy of the particles increases, their temperature also increases. The particles become less dense. They rise and cooler air particles sink and replace them. And this causes convection and heats the air above the fire. Several feet to the side of the fire, you can sense the heat mostly by radiation from the flames. You're not going to touch the flames. You can still feel the heat, right? Knowing how heat moves and being able to control it allows people to use heat in many ways that benefit others. Great. Let's go ahead and talk about the main points covered here. So convection is heat transfer that happens when the particles, they carry the thermal energy as they move around, okay? So you'll mostly see illustrations of like arrows going around. That usually indicates convection currents, okay? And convection, unlike conduction, usually happens in liquids and gases. So remember, solid is with conduction. Convection usually happens in liquids and gases, right? Examples: boiling water, thunderstorm clouds. The convection current is the movement of the particles going up and down. As particles get hotter, they move faster and they spread out the area. They're moving around and carrying the thermal energy with them. On the other hand, radiation, there's no direct contact at all. There are no particles to carry that energy, right? Like the sun gives heat to Earth, but it's not touching Earth, right? Thank goodness. It radiates the thermal energy, the heat, and then it transfers. It changes it to thermal energy. And yeah, like the campfire example, you're not touching the fire, but you still get the heat. Examples are the sun, toasters to toast bread, microwaves, light bulbs, all that good stuff. And we can see conduction, convection, and radiation in action in a campfire. How? Conduction is happening here. Convection is happening with the circulation, and radiation, of course, you're not touching the fire, but you're still getting the heat. As you can see in the conduction process, the heat is gradually moving throughout the matter, right? It starts to vibrate faster and then the heat transfers. Cool. Now, are you ready to try answering all questions about all three of these ways of heat transfer? I think you are. You can definitely go ahead and pause here and try this on your own on page 69, okay? So I want you to pause right now. Try page 69 on your own, and then resume the video and go over the answers together. All right. Great. I hope that you were able to complete this. Let's go ahead and go over the answers. Fill in the blanks. Number 1, the transfer or movement of thermal energy from one substance to another substance is called heat. That's right. And heat always flows from a blank substance to a blank one. So warmer to cooler or cooler to warmer? Of course, it is warmer to cooler. Of course, Miss Oak, that is so obvious. All right, next, identify the method of heat flow. Write CD for conduction, CV for convection, or RD for radiation. Number 3, occurs when particles of substances bump into and touch each other. So we know right away it's not radiation, because radiation, there's no touch involved. So this happens when particles of substances bump into each other. Well, that, ladies and gentlemen, would be conduction, right? So we're going to write CD. Number 4, occurs when particles of a substance carry the thermal energy, like a piggyback, as they move from one place to another. That is Yup, convection. Number 5, occurs when there are no particles to carry the energy. So if nothing is going to carry it, it's just going to be radiating. So that is radiation. Number 6, can occur through empty space. So for example, if you're warming yourself by the campfire, you're feeling the heat through this empty space. What example is that? Aha, radiation. Number 7, usually occurs in liquids and gases. What is that? Convection. Great job, guys. You guys are killing it. Number 8, light from the sun. Light from the sun is an example of radiation. It's a way that solids are often heated. So that's kind of a different kind of question. So convection, we know it happens in liquids and gases. What type of heat transfer usually happens with solids, guys? If you said conduction, you are correct. Number 10, boiling water. So boiling water. Think about all the currents. What are those currents called? Convection. Currents. Number 11, cooking on a stovetop. So cooking eggs. How does the heat transfer there? Fire's touching the pan directly, so that is conduction. 12, wind that helps form thunderstorm clouds. Thunderstorm clouds, think about the currents again. So we have convection. Yep, that's right. Number 13, making toast in a toaster. That is our wonderful radiation that allows us to eat delicious bread first thing in the morning. And 14, a melting ice cube in your hand. That one's a little tricky. So think about an ice cube. You can even put one on your hand if you want. How is the heat transferring from your warm hand to the ice? Well, first of all, it's not radiation because you're touching it, right? It's direct contact. The ice isn't moving, so it's conduction. Great. Answer the question, how is radiation different from conduction and convection? So to answer this question, ask yourself, what do conduction and convection have in common? Something that they share that radiation does not share. So radiation, there's no direct contact. There's no touching at all. You don't need a matter to transfer the heat, right? However, in conduction and convection, you do need matter in order to transfer it. You can actually see this on page 99. Both conduction and convection need matter for heating. Radiation, however, happens without the particles directly touching or particles moving. So that is the difference. Radiation is different from conduction and convection because, while conduction and convection both need matter for heating, radiation does not need. Radiation does not. Radiation happens without particles touching or moving. Great job. Go ahead and watch the video that is in the playlist. Conduction, convection, radiation does a really, really good job summarizing everything, so it will be stuck in your brain and it will help you understand everything better, okay? Otherwise, that is it for science class. Super proud of you. Great job as always, and I will see you in reading. Bye.